to you. Now, the way it works is if you've got the extension here installed, the Unreal for Snippets by Captain Caps, this actually gets a little bit easier because you don't have to remember all of the complexity of the syntax. You just type ulog and it will pop up with an IntelliSense dialog like this saying ulog to help you write out the whole piece of code, and you can hit enter or select it with your mouse, and then what you're going to see is it's written out something that looks a bit like a function. It's not actually a function under the hood. It's got some little bit of Unreal magic going on here, but it's essentially a bit like a function. So what we're going to do here is we're passing in a couple of arguments to this function. The first one tells us what type of log category we are doing. The second one tells us the level of the log, so how urgent it is essentially. And then finally we've got this thing here, which is basically a function within a function, which tells us the text that we need to print out. So how does this work? If we just leave this in our code, go over into Unreal, hit compile, we want to see where does it show up. Well, once the compilation has finished, we're going to go ahead and hit play. And what you're actually looking for is it's not going to be up on the screen here. It's going to be in the output log down here. and you can see it just about here saying display your message, and we've got how many messages? 1, 2, 3, 4, 5. The reason for this is it's displaying the message for every single actor in our scene that is a moving platform CPP. So that is why we're getting so many messages. And you can see we can change out the message to be whatever we wanted it to be here. And we could also put some more information into this message, such as the start location or the name of the actor, things like that. So here we go. So we've got an output log, we've got our message, and you can start to see what the categories I was talking about are. You can see we've got log temp here, but up above we've got log audio mixer, log world. So they're different categories of logging that help us distinguish where is this message coming from, which part of Unreal is this coming from. But log temp is mostly what we're going to use because it's just a temporary place for logging out debug messages. And then there's display. This is the default level, log level, but we can have messages be a bunch of different things. It can be display or any value from this table down here. So you can see display here, it prints a message to the console and the log file. We've got the log down here, which prints a message only to the log file and doesn't display it in the console. So this is for things where you don't really want it to show up so much, but might want to use it for debugging. If you're debugging someone's game and it ran on their machine, they're sending you a log file. Then you've got warning. This is when things seem to be going wrong, and it prints it to the log console, and it is also in yellow. Then we've got error, that prints it in red, and then fatal basically prints it to the console and crashes the engine. So you kind of want to use this one as a last resort, but it does allow you to have different levels in the log file, and I'll just show you what it looks like if we put in different messages here. So I'm going to copy our line for logging, and I'm going to make 3 of them. We're going to have a display, we're going to have a warning, and we're going to have an error. Now these are typically the levels that we will use, so let's go ahead and have a look and see what they look like. Let's go into Unreal, hit the compile button, and let's stop and restart play. And by the way, you can bring up the output log by hitting the tilde key twice. It brings up, there you go, we've got our output log, and you can see we've got 3 sets of message: the display, which is just in plain white, warning, which is in yellow, so it stands out a little bit more, and error, obviously, which stands out a lot more. Now we can add data to our log messages. I'm just going to delete the warning and error lines of the log, and we can add in some data into this string that's going to be printed out. The way we would do this is, for example, if I wanted to print out the move distance configured for a particular platform, that's fairly straightforward to do. We can say configured move distance, and that's the text that's going to show up. I'm going to put a colon in here, and remember this is all within the double quotes to make sure that we're including it in the text. And then we can use a % sign followed by the F character. and you see that gets highlighted differently because this is what is known as a format specifier. It's something that comes from C all the way back in history, and essentially usually you do a percentage sign and then some letter. You can see the different letters down here. The F corresponds to a decimal floating point, and you can see an example of what the output looks like over in the example column. And there's lots of other things down here. We can represent with D or I a decimal integer like so. So we're using F because we've got a floating point number. And then what we have to do is add in another argument to the UE-log function. So make sure that you are doing this after you've closed the brackets for this text function, and instead we're putting a comma after here. So between these two brackets, it should be inside of the outer set but outside of the inner set, if that makes sense. And then what we can do is we can pass in the value of our variable. So we can do the move distance variable like so. Let's go over into Unreal and see this in action. I hit the compile button, close down the compile window and hit play, and then hit tilde twice to bring up the log, and you can see our configured move distances showing up for the different platforms. 500 and 500 for the two moving platforms, and 1500 for the three pushers that we've got in the scene. So one piece of information that might be a little bit interesting or instructive is that we've previously talked about how we overshoot, or we did overshoot, the distance moved. And it'll be interesting to know by what kind of levels that is happening. So what we could do is we could create a float variable inside the if statement. So we know that we've currently overshot. We can say overshoot, a float variable called overshoot. We're going to set it equal to the distance moved minus the move distance. So that tells us how much the overshoot was. So I'd like you to have a go at logging the overshoot. The move distance, so that tells us how much the overshoot was. So I'd like you to have a go at logging the overshoot variable that we've just created here. So use the UE log function. Here it is for reference, at least the kind of structure that you will probably be using. You can also practice using that ulog autocomplete to put it in instead, and then compile and test your code and see if it works. Pause the video and have a go. Okay, welcome back. So we're going to use the autocomplete option here. I'm just going to close down my sidebar to have a little bit more space. And then inside this if, after we've created the variable, we're going to type ulog and hit enter. And then we're going to leave it at display. We're going to make the text platform overshot by, and then we're going to use %f, and then between these two brackets, we're going to add a new argument for the overshoot variable, like so. Now, let's head back into Unreal, hit the compile button, close down the live coding log, hit play, and double tap that tilde key. And you can see that every time the platform is turning around, it is printing out a log message and saying how many units it overshot by. You can actually see that in a lot of cases, it's overshooting by quite a noticeable amount of units. 3 units or 0.5 units, that's basically 0.5 of a centimeter, 3 centimeters. It's enough that over the course of your game, these platforms could have been drifting. And that's great that we've implemented a fix for that already. Great stuff. So hopefully now you've got another tool in your arsenal for trying to figure out what's going on inside your code, and later on when you are feeling more confident in making your own code, trying to figure out what's not working so well. Okay, I will see you in the next lecture. Hello and welcome. In this lecture we're going to be looking at how we can add dynamic text into our log messages using strings in C++. So let's dive in and learn about strings in C++. So we've seen how to print out some simple things from our UE log, but what if we wanted to print out some more text? Something like the actor name, for example, or even something more complicated such as a textual representation of a vector. Well, that does not typically have format specifiers because format specifiers have come to us from the age of C, which is a very basic programming language in comparison to C++, and so certain things just weren't thought up at the time. So things like vectors would not be included in the way that we format and specify them, so we tend to use strings to do this. And as we've said in the past, strings are just text variables. They are variables that contain text. So we use f_string as the type for a string. So we can have a string, and I'm just going to put in my string as the variable name for now. And how do we set a string value? Well, we've seen it a little bit around here already. These double quotes are what denote a string value in C++. So all of these expressions here, that one here where we've got the double quotes, also over in the header file where we've got the double quotes for the category, that is a string expression. So what we can do is set the myString variable from this, and I'm going to say myString value just to give us an idea of that and put a semicolon at the end of the line. And then how can we show this in a log statement? So I'm just going to remove the move distance from here as an argument to the UE log, and I'm going to change the text in the log message to say, here's my string, colon, and then instead of the F specifier, we use %s this time to denote the string that we want to print out. And then the argument we pass into the UE log function, again between these two brackets, is going to be my string. Now, unfortunately, that would be great if that just worked by itself, but unfortunately there's a little bit of a complication here in Unreal that it won't accept a straightforward string as an argument to the UE log. It needs a little bit of a converting operator here, and the way we do this is by putting an asterisk in front of the myString, and it just converts it from an F string into the format that it's looking for internally within the UE log. We don't have to go into too much detail as to why it's doing this. It's beyond the level that we need to know at this point in time. I think it's just important to learn it as it is, that when we do a %s, we always need a star in front of our F strings. So let's see if that's worked by going over into Unreal and hitting the compile button. And then we're going to close down live coding, hit play, open up the output log. And here you go. Here's my string value. So it's printing out the value in the myString. But obviously this piece of code that I've just written is not particularly useful because, well, I could have just written this string into here. Why bother with this whole substitution business? Well, where this gets more interesting is where we put a dynamic value into this variable instead. So we could do get name and call that. That is a function here available in the moving platform actor that gets the name of the actor that we see in the level outliner. We can put it into the variable. I'm going to call that variable name instead of my string and change its name down here in the UE log as well. So then we can change the text of the log message to say begin play colon, and then it's going to be the name of the actor. So let's go back into Unreal, stop play, hit compile, go ahead and hit play and open up the output log, and you can see we get the messages begin play moving platform 1, begin play moving platform 3, pushing cube 3, pushing cube 5, pushing cube 7. So we've got begin play and all the names of the different actors. Now this can be very useful because later on down the line where we're printing out our overshoot distance, it's not always clear who is overshooting in this case because they're all getting messed up together. So being able to print out the name of the actor that is producing the log message can be really helpful in pinpointing where a problem is happening. So I'd like to challenge you to log the name with that overshoot log so that we're going to see who has overshot and by how much. So you're going to add a variable for the name of the actor to tick, like we did in Begin Play. You're going to get name into it, and you're going to add a %s specifier somewhere, anywhere you like, into your log message where we're printing that overshoot. And you're going to add an argument for that name. We still want the overshoot variable in the list of arguments, but after or before that one, you're going to have to put the argument for the name as well. And it's important here that the order of the arguments matches the order of the specifiers in your message. So if you put %s before %f, then that's the order the name should go, before the overshoot. Or you should do it the other way around if you've done the other. And don't forget to add the star before your variable name to convert the string into something that the UE log can use. Pause the video and have a go. Okay, welcome back. So we're going to start off by getting a variable, and this isn't strictly necessary, but we are going to use the variable just for simplicity's sake and keeping that line a bit shorter. So we're going to have an F string called name, using uppercase letters usually to start our variable names. We're going to do a get name into that variable, and then we're going to use it as an argument. But where am I going to put my format specifier in the log message? Well, I'm going to put it as the first thing in my log message to kind of make it clear that this is a log message coming from this thing. So I'm going to put %s first, and that means that my argument needs to go before the overshoot argument. So we're going to get their name, put it in here, and we need to put an asterisk in front of the name in order to convert it appropriately. Now let's go back into the editor, stop playing, hit recompile, close the terminal, hit play, and open the output log. And you can see that we're starting to get our tick messages coming through. Got pushing cube, overshot by 1, pushing cube, 1, 1. So you can see here, you can make a conclusion that we couldn't make before, which is that the faster moving platforms, the pushing cubes, are the ones overshooting by more, whereas the moving platforms seem to be overshooting by less, which is what I would expect, but it's good to see it confirmed here in the logs. Great stuff. So that's it for our little logging diversion. Hopefully you found this interesting, and I will see you in the next lecture. Hello and welcome. In this lecture we're going to be implementing our own class member functions, move platform and rotate platform. We're going to see how we can set them up so they can take in arguments, and this is going to help us tidy up our code a little bit. Let's dive in and see how this works. So up until now, we've been using the C++ functions that have already been created for us. We've been using tick, we've been using big and play in terms of writing their functionality, and we've also been using functions that other people have written for us. We've been calling them, such as get actor location and get name. Now, how can we go about creating our new own functions to help organize our code and keep these functions small and everything much more legible? Well, we've got the basic building blocks already in place. By getting towards the end of the section, we understand a lot more about C++ syntax. So what I want to do is essentially create a new function on the moving platform that allows us to have, just in tick, say call move platform. Why do I want to do that? Well, because being able to make a function call like this called move platform, it really speaks to what we're trying to do. At the moment we've got a lot of stuff going on in tick, and I'm not entirely clear why we are doing all this stuff if I just come and take a glance at it. If I went into tick and saw a function that says move platform, well then suddenly I have the context for what all this stuff should be doing, and I don't need a single comment to tell me what's going on. And this is going to be particularly useful when we add into the mix the possibility of rotating the platform as well. So how do we declare functions? Well, the declaration aspect is done over in the header file. That's where we basically say, heads up to C++, we're going to have a function that's going to look kind of like this. And then over in the C++ is where we actually define the function. We give it the body, we tell it exactly to C++, this is how the function works. And let's have a look at how we can do this. We've got a few examples of functions, and we've got begin play, we've got tick, and it's a good point in time for us to look at the different sections that we've got in our header file. We've got public and protected being mentioned here, and public being mentioned again. Now what does this mean? These keywords with the colon at the end basically define a section of accessibility. These functions, where can they be accessed from? We've seen over in the getSafeNormal, this is a function that we're calling on an F vector, but we're calling on it from another class, not from within an F vector. So this means that the accessibility of this function needs to be public. Now, we'll leave aside protected just for the minute because it gets a little bit more complicated there. But there is another type of keyword that we can use, which is private. So I'm going to add, after tick, I'm going to add the private keyword. Notice that I don't indent these sections. And we're going to put a colon at the end. And that means that everything that comes afterwards until the next section, the next keyword that I put in here, is going to be private. So that means we've taken all of these variables and said, hey, no other class is allowed to touch these. And that's usually the best practice. We haven't done it up to this point because I didn't want to get things a little bit too confusing for you. But variables in classes should generally be their own business. It's one of the core tenets of object-oriented programming that we leave classes to manage their own variables and we only access them using functions that the class denotes as being public. So what we're going to do here is we're going to add some more private functions in here because we don't want something like move platform to be called from outside of the class. We want it to be managed by our own tick function. So how do we define a private function? Well, we put it in a private section. So we've got our private keyword up here. I'm going to put it after our variables, however. And we start off with the return type. And if our function doesn't return anything, we just type void to indicate that there's no return coming out of this function. Then we give it a function name. So we had move platform was what we wanted. And then we give it some parentheses to indicate that this is a function. Open and close parentheses, and then a semicolon to finish off the line and say, okay, that's it. That is the function that I want to declare here in the header file. And all that does is says this is the shape of the function, this is the return, this is what parameters it takes, and the name, and which class it belongs to. Now, to actually give it an implementation, we have to define it over in the C++ file, so let's go over there. And at the end of an implementation, we have to define it over in the C++ file, so let's go over there. And at the end of the file, just outside of any curly braces, this is where we do it. We start again with the return type, so that's going to be void. Then, because we're inside a C++ file, we're not inside the curly braces of a class, we have to use the scope resolution operator to say that we're trying to define a function from within the moving platform class. So we type the name of the class, which is a moving platform, remembering that a prefix is there to say that it's an actor. Then we use colon colon, the scope resolution operator, and then we use the name of the function we're defining, which is move platform. And then we use the same set of parameters as we did in the header file. In this case, we had an empty set of parameters, so we just have the parentheses. And then, instead of putting a semicolon at the end of this line, on a new line, we put an opening curly brace and a corresponding closing curly brace. And between these curly braces is where we put the code for our function. Fantastic. So what I want to do now is try and say, well, all of this functionality we've got here, and in fact, I'm going to delete the comments because we no longer need them. They were the pseudocode we used to implement this, but now it's kind of served its purpose. We understand what the lines of code are doing. I'm going to take everything but the move platform function out of tick and copy it and paste it into our move platform function instead. So this should work pretty much the same because when we go into tick, we then call move platform and it just runs the same piece of code, except now we've bundled it into a function and it makes it easier for us to read and potentially reuse in the future. But if you do this, you will notice there is a problem. We are accessing delta time, and that is a parameter we no longer have access to because it was a parameter passed into tick. So if we want to get hold of that, we do need to have a parameter in our function. So we're going. It's easier to give it the same name because then it's obvious. to anyone reading it what should be passed in here. Then over in the C++ file, we need to match the list of parameters. So again, you can just do this by copying and pasting or by typing it out. If you type it out, make sure you don't make any typos because the compiler will complain. So we're going to have a float called delta time passed in as a parameter, or defined as a parameter to move platform. But we haven't actually passed it in as an argument to move platform in tick. And you'll see I've got a little red squiggly line here. If I hover over it, it says there's too few arguments in the function call, because I've defined it in the header file and now in the C++ as well as requiring one parameter of type float. So I must provide that parameter. So I'm going to make sure that the parameter I'm providing, the value that I'm providing, comes from the delta time variable, or the delta time parameter from tick. So we're threading the value gets passed into tick, it then gets passed into move platform and ends up in our parameter in the move platform function, where it can be used to execute our move platform functionality. So I'd like you to create your own rotate platform function that we're going to call from tick. So you're going to add it to the header file like we've done for our move platform function. We're going to add it to the C++ file in the same way as well. So take your hints from the way we did it for those functions and then call it from the tick function. From parameter I'm providing, the value that I'm providing comes from the delta time variable, or the delta time parameter from tick. So we're threading the value gets passed into tick, then gets passed into move platform and ends up in our parameter in the move platform function, where it can be used to execute our move platform functionality. So I'd like you to create your own rotate platform function that we're going to call from tick. So you're going to add it to the header file like we've done for our move platform function. We're going to add it to the C++ file in the same way as well. So take your hints from the way we did it for those functions and then call it from the tick function. Make sure you pass in delta time and you define any parameters to allow you to pass in the delta time, and implement the body of the rotate platform so that it logs out a message. It's not actually going to rotate the platform yet, but as a placeholder to make sure that that is actually getting called, print a log message using the UE log that we've learnt about. Pause the video and have a go. Okay, welcome back. So we're going to start off in the header file, and we're mostly going to be doing the same as we did for our move platform. We're going to put it in a private section so that it's only accessible within our class. We're going to give it a void return type. We're going to call it rotate platform. We're going to open up the parameter list, and in it we're going to put one parameter, which is going to be of type float. We're going to call it delta time, and close the parameters and finish off with a semicolon. Now, most of what we do over in the C++ file is exactly the same as in the header file. So I'm actually going to copy this line, go over to the C++ file and show you what is different. So I'm going to go to a new empty line at the end of the file, paste it in, and then what's different is over here we need the scope resolution operator and the class name. So we're going to have a moving platform colon rotate platform. Then we have the parameter list, and then we don't need the semicolon on the end, so we remove the semicolon, add in a new line, and add our curly braces instead, and a new line between those two curly braces. So what we want to do in here is print out a log message. So I'm going to type log, hit enter. It's just going to be a simple display message, and in the text I'm going to put the name of our platform. So it's going to be %s, then we're going to type rotating ... and then I'm going to pass in the name. Now we could put this into a variable, but because it's quite a short line here, I'm just going to type star get name and then put the parentheses, so that we're calling, essentially here, calling the get name, that is the expression that gets hold of the f string, and then we are converting that result to put into our log message. So from all of our platforms, I'm expecting to see that rotating is printed, but this will only happen if I actually call it in tick. So let's go up to the tick function. After move platform, I'm going to add a new line and call the rotate platform. And we need to, you see when I open up the parentheses, it gives me a hint that I need to pass in an argument for delta time. So again, we're just going to pass that same delta time variable from within here. And like I said, the names here don't have to be the same. So this delta time needs to match with the delta time within tick. But we could choose to call the variable within rotate platform dt instead. And anywhere we use it within rotate platform, we'd have to use dt. The name of the parameter and the argument can basically be different. So let's hop over into Unreal and hit compile. Because we've made some changes to the header file, the compilation will be slightly longer than when we just changed the C++ file. And once that's completed compiling, we're going to go ahead, hit play, and open up the output log. And you can see that we are indeed displaying log messages about each of the platforms rotating. So it looks like our function is effectively getting called in tick. Great stuff. Now we understand how to create our own functions that are members of a class. It's a very useful tool for reusing a code, but also for organizing it, just like it was in Blueprint. I'll see you in the next lecture. Hello and welcome. In this lecture we're going to be looking at how we can return values out of our functions using different return types and a return statement. Let's dive in and see how this works. So last lecture we said that if our function doesn't return a value, then the return type should be void, which is what we've done here. But what if we wanted to take a function such as basically checking whether we should turn around? this function here in the if statement, if we could say should turn around instead, it would be a much cleaner function at the end of the day. So how do we do that? How do we achieve a function that can return a Boolean expression? Well, the way we do it is simply by using a type instead of the void. So if we were to want to return a Boolean expression, we could type bool like we would for a variable. But the thing that distinguishes the function from the variable is the fact that we put parentheses after it. That makes it a function rather than a variable. And what we could do is call it should platform return. And then we put our parentheses, and in this case I don't have anything that I want to pass in as an argument to this function, so I can just leave the parameter list empty, put a semicolon at the end of the line, and then copy this entire line and go over to the moving platform CPP. And right at the end of the file, you could put it anywhere you like, really, between any of the functions. Just make sure it's not inside a function. I'm going to paste it in here. I'm going to unindent it, and I'm going to add the class and the scope resolution operator. So a moving platform : should platform return, then remove the semicolon and add some braces instead. And what we want to do here is, if we want it to actually return a result, we need to use the special keyword return followed by an expression of the correct type. So in this case it has to be a Boolean expression. So I could return true and then put a semicolon at the end, or I could return false and then put a semicolon at the end. But it doesn't have to be that simple. It could actually be any expression. It could be another call to a function. It could be a variable. It could be a use of some operators, as we have up here inside our if statement. So in fact, let's go ahead and try doing that. I'm going to take this expression, the distance moved, and is greater than move distance. I'm going to cut it out, and I'm going to put it as the return expression for the should platform return function. You notice it's going to complain here because distance move isn't a local variable within our should platform return function. So we're going to have to move some more things over. But before we do that, I don't want to forget to put a call to the should platform return in our if statement. So should platform return, and then remember to put the parentheses so the function actually gets called inside our if statement. So now it's starting to read a bit better to me. If platform should return, then we do all of the following. So now what we need to do is bring across the distance moved variable that we've got in move platform. We don't actually need it inside move platform. I'm going to cut it out and bring it and put it on the line before our return statement. Usually the return statement is the last thing in a function, because once you've returned out of a function, you actually don't do anything else. If I were to put something like a log message, so I'll put a ulog after my return statement with some sort of message, usually what's going to happen is you'll get a warning from your compiler saying that this line will never be reached, and that you probably didn't mean to do that. So the return statement usually is the last thing. So having moved across the line that defines the distance moved in our should platform return function, you can see it's now saying, hey, I don't have a current location. And well, the current location we can just very easily grab. We've set the current location just before we're calling should platform return. So actually get actor location is exactly what we want. So I'm just going to put that instead of a variable. I'm just going to put a call to get actor location in the place in should platform return. So now what we've got is the distance moved is equal to the f vector distance between the start location and the get actor current location. So if that's greater than our configured move distance, then yes, the platform should return. That's what this function is saying, and it allows us to use it at a higher level of abstraction from within a move platform function. Now you'll notice that it's now complaining that we can't get the distance moved to print our overshoot. Well, that's no big deal. I don't actually want to print that anymore. It's kind of messing up my function anyway, so I'm going to delete the overshoot variable line. I'm going to delete the get name line. I'm going to delete the log message because it was only there temporarily, hence the log temp name. So now our move platform function is starting to look a lot cleaner. We can see that we are doing some updating of the location here. We can see whether the platform should return, and if it should, then we are updating the location and flipping it around. Now, one thing that I think would look a little bit better here is if we had an else statement instead of having this bunch of code up the top. So if the platform should return, we will execute this, else we will execute the normal code in terms of moving it forward. So remember, you cast your mind back to when we talked about the else statement. It just comes after an if statement, and we just do it like this. After the braces, we have a new line and type else, then another new line and open some new parentheses, and then we can just move this code that's up here at the top of our tick. We can take it and move it down into the else statement. So now it seems pretty straightforward. Should the platform return, then do the code that does platform returning, else we're moving the platform forward with our platform velocity. Now I'd like to challenge you to create your own function with a return value. I'd like code, and we can just move this code that's up here at the top of our tick. We can take it and move it down into the else statement. So now it seems pretty straightforward. Should the platform return, then do the code that does platform returning, else we're moving the platform forward with our platform velocity. Now I'd like to challenge you to create your own function with a return value. I'd like you to add a getDistanceMoved function. So we've currently calculated this into a variable called distanceMoved. I'd like you to replace that with a call to a function instead. So it should return a float, because that's how the type of distance moved. We should call it in should platform return. So instead of using the fvector_dist, we should be using our own implementation. So what code should it contain? What code should we put into it? The hint is that we've already typed this code, so you are just copying and pasting it into the new function. But have a little think about what the return expression should be, such that what we're returning is the distance moved value. pause the video and have a go. Okay, welcome back. So let's go over to our header file. We'll add a new function here with a float return value called getDistanceMoved, and then we're going to have no arguments in the parentheses, and then we're going to go over to our moving platform CPP. We're going to add in a float, a moving platform, distance moved, or get distance moved, I should say, parentheses, and then we'll put a new set of braces on the next line. And what we want to return is literally just the expression we're using to create our distance moved float. So I can cut that out and paste it in here. So it's f vector : dist start location get actor location, and put a semicolon at the end of that line. And that means that in should platform return now, instead of having this distance moved variable, I'm going to delete that line that's half completed. We're going to return get distance moved, parentheses, is greater than the move distance. So we've kind of taken what was going into a variable and pulled it out into its own function instead. And this means that whenever we want to refer to the distance moved, if we did want to have kept that log message in move platform, then we can easily just call the function getDistanceMoved from any of the functions in our class. Great stuff. So in this lecture, we've learned about return statements and return values, and we've used them to create two new functions in our class. I'll see you in the next lecture. Hello and welcome. In this lecture we're going to be looking at the C++ equivalent of pure blueprint functions, which is const functions. We're going to see what this const keyword is, how we use it, and how it restricts what we can do in our code to make us safer. Let's dive in and see how it works. Over in Blueprint, we were able to make a function pure, and that meant that we could take away the need for the execution pins. Now, in C++, we can do something a little bit stronger, which is to make a function const. Now, what does it mean to make a function const? It means that that function cannot modify the state of your class, and it is actually enforced by the rules of the compiler. So, let me give you an example. If I were to take our should platform return function, this is not a function that should modify anything in the class, and it would be an error really if we forgot that, because it would be weird if calling this and using it in an if statement actually changed the location of the platform, or if it updated the move distance or platform velocity. So to keep ourselves honest to that, we can make it const. And the way we do this is by putting the const keyword after the parentheses of the function. We often leave a space here as well. Now, in order for it to correctly match up to the function in the C++ file, we actually have to put that const keyword over there as well. Now, like I said, this now makes it an error to do anything that would modify the class. So if in should platform return were to try and modify a class variable such as move distance, I might try and set move distance to 200. Let's see what happens when we go over to Unreal and hit the compile button. Okay, you can see that there's now an error. It does fail to build, and if you look at the error, you can see that there's something being said here about not being able to modify something because it's being accessed through a const pointer. Now, don't worry about that language, it's a little bit hard to interpret, but the point is the keyword const was there and it's saying it's not able to modify something. And that is crucial. Also, if you called any functions that aren't marked as being const, that's also a problem. So while it's fine to call getActorLocation, that is a const function, doesn't change anything, just gets the location. It's not okay to call setActorLocation. That hasn't been marked as const, and so it's not valid. It could be modifying the class. So any function that's not marked as const is not allowed to be called from within a const function. And so you can see a problem emerging. We can't actually call getDistanceMoved from within our shouldPlatformReturn because shouldPlatformReturn is const, but getDistanceMoved hasn't been marked as such. So quick challenge to you, get the distanceMoved const, make getDistanceMoved const. So in the header and CPP file, you're going to add that const keyword to let C++ know that it shouldn't modify the class. And does it compile now? Pause the video and have a go. Okay, welcome back. So we're going to go over to the header file first, and after the closing parentheses, we're going to add a space const, and then we're going to go back to the C++ file, and after distance moved parentheses, we're going to put space const. Now, the squiggly lines under get distance moved should update in a little bit of time, but if we go over to Unreal and hit the compile button, that will be the ultimate arbiter as to whether the compiler likes what we've done or not. And this time the compilation has succeeded successfully, which means that we have correctly updated our code. And that makes sense because there is nothing being called from getDistanceMoved that is not const, it's not trying to change anything, and where we are calling a function in shouldPlatformReturn, we are only using const functions. And this is a way for us to increase the safety of our code because functions won't be changing stuff without us knowing about it. Now, as a little exercise to yourself, you might want to go through and look at all the functions that we've been using up to now and see which one of them are marked as const and which ones aren't. You can do this by simply hovering over a function such as getActorLocation and seeing whether the pop-up that is included, whether after the parentheses it has const or not. You can see with getActorLocation, hovering over it gives me const. Hovering over getName also gives me that this is const, and it makes sense. Neither of those two should be changing the state of our class. Now, if I hovered over tick, you can see this one isn't marked as const, and that makes sense because tick is usually used for updating how a class is positioned in the world or any of the state of the class. And we've got our vector. If we hover over getSafeNormal, you can see that it's marked as const. That's because getSafeNormal doesn't actually modify the vector, it just returns a value with a new vector in it. So that's it for this lecture. We've learned about adding const to our functions to increase the safety of our code. I'll see you in the next one. Hello and welcome. In this lecture we're going to be making rotating as well as moving platforms. We're going to do this by learning about the F rotator type in C++ so that we can add a little bit more of another element to our puzzle. Let's dive in and find out how this works. So let's talk about filling out our rotate platform function. So in order to do rotation, it's very similar to the way we do location, and we've got very similar functions we can call. Instead of calling getActor location, we can call getActor rotation instead. And if I go and put parentheses on the end of this line and just hover over the function, then Visual Studio IntelliSense is going to show us that the return value from this is an F rotator. We've used the F vector when working with locations, and we've talked about rotators in the previous sections. So let's have a look at putting this F rotator into a local variable. So the type's going to be F rotator, and we're going to call this the current rotation equal to the getActor rotation. Put a semicolon at the end of the line. I'm also going to delete the log statement because we no longer need that. And then what we want to do is essentially exactly the same as we've done with the platform velocity, which is a kind of rotational velocity multiplied by the delta time added to the current rotation. So what should that rotational velocity be? Well, that's where we want to go over to the header file and add a new U property. So I'm going to add it underneath the move distance, and I'm going to have a U property, edit anywhere, and then give it a category equal to, this time we're going to call it rotation, and I'm going to change the category name from moving platform to moving in both instances. So we're going to have a category for moving, a category for rotation. Then underneath the U property, we're going to put an F rotator called rotation velocity. And we're not going to give it a default value here because by default I don't want any of our platforms to rotate. So the default value is going to be 0, 0, 0, and that's just what we need. So I'm going to put a semicolon on the end of the line here. And now we can go back over to the C++ file and use that member variable in our rotate platform function. So what we want to do is current rotation equal to the current rotation plus rotation velocity. Use rotation velocity, and we're not going to give it a default value here because by default I don't want any of our platforms to rotate, so the default value is going to be 0, 0, 0, and that's just what we need. So I'm going to put a semicolon on the end of the line here, and now we can go back over to the C++ file and use that member variable in our rotate platform function. So what we want to do is current rotation equal to the current rotation plus rotation velocity multiplied by delta time. We'll put a semicolon on the end of the line. And now the final piece of the puzzle is to set our actor to that new rotation. So exactly as you would expect, maybe a little mini challenge for you in fact, is how would you go ahead and do that yourself? Well, what we would use is the setActor rotation function, and we would pass in an argument of current rotation, like so, and put a semicolon on the end of the line. Now, unfortunately, it doesn't work quite as simply as this. It's come to my attention, some students have pointed out, and the teaching assistant, Dan, thank you very much, has pointed out that just adding rotations together like this won't always work because of some of the complications around rotations wrapping around themselves. You go all the way to minus 90 degrees of rotation. At some point you need to flip over into plus 90 degrees of rotation, and so on and so forth. So a better way around this, instead of setting the actor rotation, is to call the add actor local rotation. And you can notice here that there are a few add actor local transform as well, and local offset, that's for location, so you can use that as well instead of adding location. However, there aren't the same sort of problems that we're going to encounter in the edge cases around rotation. So what I would recommend you do is add actor local rotation here instead, and then you just put in the rotation velocity multiplied by the delta time, and it does the rest of this code automatically for you. So we can just go ahead and get rid of those lines, and you've got a straightforward addition to the local rotation going on here. And you can also get rid of this getting the current rotation because we no longer need that either. So let's head over into the editor and hit the compile button. And when that's done, close the log. Let's select one of the platforms in the level, any of them will do, and have a look at the categories. So we've got moving and we've got rotation, and we've got the rotation velocity there. So I want to rotate this platform around its z-axis at probably, let's say, about 90 degrees per second. So it takes 4 seconds to do a full rotation. Let's go ahead and hit play. And there you go, we've got a rotating and moving platform. So unlike the mechanism of the moving platform, we don't have to worry about our rotating platform actually going backwards and forwards. If you wanted to do that, that's a possible extension you could think of. But for me, that is enough, because we're just wanting these things to keep going round and round in the same direction. So let me go and remove the rotation from this particular platform, because we don't want this platform to be rotating. So I'd like to challenge you to make a BP rotating platform. Basically yet another variant for us to use, and find an appropriate mesh. I would go with something that's vaguely circular so that it makes sense as a rotating platform, and give it a default rotation speed and place it in the level to create a bit of a rotating platform. puzzle for you to get across. Pause the video and have a go. Okay, welcome back. So we're going to go ahead into our content drawer and going to look for the C++ classes Obstacle Assault and right-click the moving platform to create a blueprint class derived from this. We're going to call it the BP_rotating platform, and we're going to put it in the root of content and create blueprint class. Once the editor pops up, let's dock it to our main window. I'm going to close my content browser that seems to want to pop up every time, and I'm going to go to our main level and go to the island with all our test assets on, right click, forms hints, open up the where this is platform. Here, go to root of content and find our rotating platforms for us to get here's where being able to have a game mode really helps, because we can right click near the platforms and click play from here, and here are all of our rotating platforms for us to step upon, and it's a little bit of a challenge now for us to find our way across these moving platforms nice and easily. Now there's this dead zone in the middle which we could try and blank out, but it's actually quite hard to get and stay in the dead zone, so I'm not going to try and put anything in there specifically to try and stop that. But you can see, there you go, it's a doable challenge. We can get across, but but it's a little bit tricky, and that is fun. Great stuff. So in this lecture, we've seen how to make rotating platforms by learning about a new type, the F-rotator, and how we can use it to set the rotation of our actors. I'll see you in the next lecture. Hello and welcome. In this lecture, we're going to be implementing a level design for our obstacle assault course. You can see here I've added in some more islands and a little victory end zone at the end. We're going to talk about my process for doing this and getting out some pen and paper and making our own level designs. Let's dive in and get started. So let's try and spend a moment to design a level out of the different components we've got here. Here's my approach. I'm going to start with what kind of permutations and options of obstacle do I have? So what elements can I play with to design this level? We've got rotating versus moving. That's one of the key elements we could fiddle with. We got up or down or left and right. So you could have platforms that transport you across a gap. You could have up and down to take you up a level like we've already shown. We've got the pushing/transporting option. So platforms can be used to push you off of something, so they can be an obstacle to avoid, or they can transport you, in which case they're an obstacle that you want to get on. So those are some of the options that we've got available here. Let's have a look, in this case, at a simple linear course through our obstacle assault course, where basically the whole objective is just to get from the start to the end, and there aren't any kind of diversions. You can't take a shortcut, you can't take an option B path. So what I suggest you do is you take this and you take a sheet of paper and you get away from your computer for a little bit and just brainstorm a few different designs. I recommend that you try fitting the design on one sheet of paper so that you just limit the scope, because it's very easy to get carried away with all the amazing things that you could do and just take on a little bit too much. So we're going to try and limit the scope to just one sheet. In my case, it was a sheet of A5. You can have a sheet of A4 if you want to. Here's the example of what I've come up with, really very quick and dirty, just to give me an idea of what I want. And this is just going to be something that I can adapt later on. And you can see it's incorporating some elements of the design that we've already got. We've got the up and down platforms that take us up to a second level. We've got the pushers going backwards and forwards. We've got these rotating platforms that we need to get across. Then I thought maybe it would be nice to have the idea of a sweeper. So something like a pusher where it rotates around and tries to sweep us off the platform. Something like that, and then we'll have some goal at the end, maybe something to reach that looks cool and makes it clear that we've got to the end of the obstacle course. So that's my idea, and I'd like to challenge you to make your own level design too. So limit yourself to one sheet of paper, as I said. Share your results once you're done. Choose the design you like the best and share it in the discussions before you go and implement it. And then try and implement it for yourself. We've seen how we can make different blueprints for different elements, so you might have a few more elements that you've incorporated in your design, so you can go ahead and make a few more blueprints and put them in the world. So let your design adapt as you play it as well. Once you've written it on paper, you don't have to stick to it. It's not a rule, it's just an idea to get you started. So pause the video and have a go. Okay, welcome back. So the bit that I wanted to add on top of this level design that we've already got is perhaps we'll add a second platform in here, and we'll rotate it around so that it doesn't look the same, and lift it up just another level. So this is what I mean. I'm already adapting the design because I've noticed that I don't have any more space on this platform to put a pusher in there. And then there are some stairs down here. I kind of like those, so I'm going to take a copy of this ramp and try and paste it down here. I want to actually move it up to the platform somehow. So what I might do is take the location of one of these rotating platforms and copy it, and click on the ramp that I've duplicated and paste the location so that it comes up here. Excellent. And now I'm going to try and position this ramp so that it takes us up to the next platform. So I'm going to have to adjust the height of the platform and adjust its position somewhat as well. so that it takes us nicely up there. So this is where using the play from here, it comes in really handy. If we right click on just after we've gone past our rotating platforms, click play from here and see if we can get up these stairs. Looks like we can't for some reason. I think the angle of these stairs is a little bit too steep. So how can we fix that? Well, I can go over to the third person character and I can click on its movement component. And here there's a bunch of properties about how this character walks. And you can see one of them is the walkable floor angle, and it's set to 44 degrees. So it looks like we've got a bit of a steeper set of stairs. So I'm just going to set this to 60 degrees to make sure we can make our way up it. Then we're going to play from here again and see if we can get up there. Yep, sure enough, we can go up those stairs now that they're a little bit wider. Now the platform's a little bit down, so I'm going to adjust that, and then I'm going to try and make a sweeper. So we're going to go to our C++ class, we're going to right click on it and create a blueprint class, and I'm going to call it the BP_sweeper. I'm going to put it in the root of content. Then with that open, I'm going to go to our content drawer and search for, well, I quite like the look of these archways without getting, but that's kind of cool, and search for out the force field. So we've got the gate a little bit wider. So I'm going to use the scale tool and just extend them a little bit along the x-axis. And I'm going to save that. Then I'm going to look at our sweeper, and we're going to not have it move, so set its platform velocity to 0, but set its rotation. This time I'm going to go in the opposite direction at about -100, so it's going to be a little bit faster and a little bit more challenging because we're later on in the level. And then we're going to try and navigate back to our island. So I'm going to click on it and click go here. And then on top, we can start placing down these sweepers. So clear my filter and start getting some sweepers and sticking them on the island. And we can rotate them a little bit so that they are all at different offsets from each other. Duplicate them with Alt a little bit here. Like I say, I'm rotating some of them to everything start slightly differently. Let's click play from here in the safe zone of our previous platform, and then come up and have a look at what these sweepers look like. So yeah, it looks like they could definitely be pushing us if we don't watch ourselves, and we might fall off the platform if we're not careful. So we have to be a little bit careful or we're going to fall to our death. So it looks like a fun little puzzle with these sweepers. And now all we have to do is put a little end zone in. For this, I'm basically going to copy this little courtyard area that they've created here in the standard kit. So I'm going to select the stairs, and well, there's quite a few things here that I'd want to select. Let's see if they've grouped them together in the outliner first of all. So it looks like there is a folder called Castle, so maybe we can select everything that is under that folder. So we can right click it and select all descendants. So what I'm going to do is actually use it in place and just move that island up to be at the foot of the island that we have just traversed here. So now it should be possible to play from here, to go inside one of the pushers and then try and escape. There we go. We can get up to the Victory Island, and once we've got to the castle, that can be the goal of the entire game. So one thing it looks like I messed up by moving that island is that it seems that I've moved the ramp that was under the same folder in the outliner. So the ramp between our rotating platforms and our rotating pushers has been moved. So I've just positioned that back. And if we zoom out, we can take a look at the entirety of our level, from our start over here, moving platforms, pushers, rotators, and sweepers, all the way to the little victory end zone. So I'm pretty happy that that's a fun level, and obviously you should give it to other people to play test and tweak your ideas and maybe implement a few different level designs. But for now, I'm quite happy with that, and I'll see you in the next lecture. So it's been an absolutely jam-packed section. Let's see what the highlights have been of what we've learned. So we've learned about the structure of our C++ syntax, about statements and expressions, and some of the basic stuff like local variables and if statements and braces and all of that good gubbins. We've learned how to create classes in C++, the idea of a header file versus a C++ file. We've looked at member variables and member functions and how we can declare them and what it means for them to be members of the class. We've looked at creating blueprint child classes off of our C++ so that we can use a bit of the best of both worlds. We used some of Unreal's built-in functionality such as the U property and the UE log to communicate with our editor. And we've used some Unreal types, the F string, the F vector, and the F rotator. We've been introduced to all of these and used them somewhat. And we've looked at some of the Unreal classes, such as the game mode and character class, and how these work together. In making games easier to build in Unreal. Now, there are a couple of extensions to this project that you could try if you wanted to take things a little bit further. First of all, I would suggest trying to build some more levels and playing them and testing them, that sort of thing, and inventing some new platform types, so some more blueprints for pushers or rotating platforms, or maybe even rotating and moving platforms. You could let your imagination be the limit here. Then rotation back and forth might be something you want to try and implement within code and see if you could think of a way of doing that. Configuring a move by its end location instead of the distance moved by a platform. You could try seeing if you could figure that out. This is probably for those of you who are more familiar with programming already though, so if you're not confident with any of these, obviously wait until later on in the course. You can always circle back to this project and improve it later on. Well, that is it for the section. I've had a whale of a time making this, and I hope you've enjoyed it too. And I'll see you in the next section. Hello and welcome. In this section we're going to be creating this game here, Crypt Raider. We are going to be looking at stealing the treasure from within this secret crypt. You can see that we come into this little bit of a jail here, and I can't figure out where I'm supposed to go. Maybe it has something to do with this illuminated floating statue. Let's grab it and bring it with us out of this cell if we can find our way out. There we go. And what about that illuminated spot there, this illuminated podium? Maybe if I stick the statue on the podium, something will happen. Oh, it's a secret wall and a hidden passage. Let's dive in and explore this secret passage. You'll notice all the lighting here is quite nice and ambient, and this is because we are using the new Lumen lighting system in Unreal. And I'm going to dive into here. Oh, we found this crypt room here and a nice golden statue that I would like to steal. Let's grab that statue. We can run away. Oh, it looks like it locks me in if I try to take the statue. So maybe I should leave it right there. And it does open up again. Maybe I can put something in its place. This urn looks like a handily placed urn. Let's try that one out. We replace the statue, throw it over here, and put the urn on top of the podium instead. Yes, it works. Let's take the statue with us and depart before anybody finds us. Up the stairs and out into the light of day. So that is our Crypt Raider project, and here is the action plan we're going to use to implement it. So the first thing we're going to do is actually tackle that level design, including the Lumen lighting. We're going to be using a modular asset pack to create this, and we're going to look at how we build with modular asset packs, how we can design for them and build something that looks really cool. Then once we've got an environment to play with, we're going to make a mover component. A component is a reusable piece of code that we can place on any actor that will allow it to move up and down like our doors did. Then we're going to create a reusable grabber component that we can place on our player and will allow us to grab objects in the scene. And we're going to call the grabber functionality from Blueprints. We're going to learn how we can do that, how we can expose C++ functionality to our Blueprint scripts. And we're going to create a pressure plate component as well. So basically a component that we can add into a blueprint of an actor, and it will allow us to respond to putting objects on the plate and allow the mover to communicate with the pressure plate in order to make that happen, and we're going to tweak and polish in the end. So what are we going to learn through this process? Well, we're going to learn about pointers and references, two very difficult concepts in C++ that are absolutely crucial and very, very powerful. And they allow us to communicate between classes, as we will need to do in this game. Then we're going to learn about actor components and scene components, what the difference is, and the benefits of using components over simply just writing our own actors. We're going to look at including header files that will allow us again to communicate between different classes and to use functionality that isn't immediately available. And we're going to look at lighting using Lumen and understanding a little bit about Lumen as well as its requirements and limitations. We're going to play with modular level design, as I've said. We're going to look at line tracing and collisions in order to enable us to create that pressure plate and also create the grabbing mechanic as well. And we're going to learn a new concept in programming in general, which we haven't touched upon yet, which is while loops and for loops and arrays. We're using data where there's a lot of data and how we can program for doing repetitive actions over that data. And finally, as I mentioned, we're going to look at calling C++ functions from Blueprint. Lots of exciting stuff to get doing in this lecture. I'll see you in the next video. Hello and welcome. In this lecture we are going to be setting up our project and bringing in the assets we need for this section. You can see we've got this lovely dungeon asset pack with lots of props, and it's fully modular, which means that we can very easily use it to create our own levels. Let's dive in and get this project set up. So for this section I'm going to be using the fantastic assets from Infuse Studio called Medieval Dungeon Pack. They are freely available on the Epic Games Store. So I do recommend you go ahead and possibly check so you can see my medieval dungeon down here, and it is 2.2 gig to download. But to download it, you will need to add it to a project. So that's the first step. Launch up your editor. Let's get to the new project pane. We're going to create one based on the game's templates, and in this case we're going to use the first person template, not because I want a first person shooter, but because I want a character that has a first person viewport for our game. So what we're going to do is I'm going to exclude starter content because I don't want that. We're going to start straight away with a C++ project in this case, and the other options, desktop, maximum, and without ray tracing in my particular case. I'm going to browse to a project location where I've already created a container folder. Now this is going to create a folder within a folder. It's a pet peeve of mine, but I can't figure out a better way to make this work with version control, which I use here, and I recommend you use if you know what it is. Then we're going to create the project name is going to be CryptRaider as well, so it's going under the CryptRaider folder. We're going to create a new folder called CryptRaider. Let's go ahead and click create. So because we were creating a C++ project, that may take a little bit of time for you, and sometimes it doesn't give you much indication that stuff is going on. But once that's done, we will get the Visual Studio Code project launched up, and yes, I'm going to hit trust the authors in this case. Then we've also got our Unreal Editor project launched up, and I've got an output log visible here. I'm just going to close that down to give us a bit more space. And let's have a little play around with what's here. I'm going to close the place actors as well and hit play. So you can see I've got some first person hands. I can move around with my mouse, and I can strafe and move like I would in any first person shooter. I can grab the gun and I can shoot at the environment around me, which is quite a cool little environment and a nice little template project, especially if you want to create a first-person shooter. You can see a lot of the stuff that's going on here, but we're going to not use a lot of this stuff. What we're going to do is add in the asset pack. So let's go over to the Epic Games launcher, go to the library tab, find your asset pack. In my case it's Medieval Dungeon, but if you wanted to use a different modular asset pack, I can recommend the Modular Sci-Fi Season 1 and Modular Sci-Fi Season 2 packs as great ways of building out modular levels in a very similar way if you wanted a different theme. But that said, I do recommend, unless you're experienced with this, you follow along with the same assets as me. So let's click Add to Project. Now we're going to have to click Show All Projects because the exact version doesn't match because of Unreal 5. So we're going to select the CryptRaider project, and you can see it's saying it doesn't have a compatible version, so we're going to choose the latest version that's compatible, which in this case is 4.26. And we're going to click Add to Project. Now when you do this for the first time, it's going to have to download the assets, which are 2.2 gigabytes, so do go ahead and set that off now, and you can watch through the rest of the video while that's working. So while that's downloading, let's go over to our content browser and create ourselves a new level. In fact, we can do this from the file menu, go new level, and I'm going to create a completely empty level, and we're going to start from there in building our dungeon map. So let's click create, let's go to the file menu and click save current level, and we're going to save it in the root of content. I'm going to call this my dungeon, and I'm going to hit save. Now we want to change the settings so that that is the default map. Let's go over to settings, project settings, into maps and modes, and the editor default startup map should be the dungeon in both cases, like so. And now if we go over to our content drawer, for me the medieval dungeon packs are already in here, so what we can do is go and have a little bit of a look. So I'm going to dive into the maps and open up the demonstration level and close down my content drawer and see what we have. Okay, pretty cool looking stuff. If we hit play, we can actually play around with this inside our first person. Unfortunately, we fall right through the floor, and that's due to there being some collision mesh issues which we'll have to sort out. No matter, we can go around the level in our preview mode and see that it does look pretty nice. There's some very ambient lighting, there's lots of different components that we can play with. This level has been constructed very nicely indeed. We've got cages, we've got lots of props, and we've got a whole kind of different set of assets down here in the crypt, slightly lower ceilings and different structure of floor floor, etc., making everything a little bit more cramped feeling in the crypt. And at the end of the crypt here, we've got the kind of pièce de résistance, which is the crypt mausoleum. And I'm going to be making use of this later on, and we can have a look and get some inspiration while it's downloading. Have a think of while I'm showing you this, what elements you like, what you might want to use in your game, because that's what we're going to be doing very soon, is designing the level here. Okay, so that's it for project setup. Let your project finish adding its assets, and I'll see you in the next video. Hello and welcome. In this lecture we're going to be pulling apart the modular asset pack to figure out what building blocks we've got and use that to put together our first design. Let's dive in. So here's the project. I've closed it and reopened it, and you can see we're in our dungeon level that's completely black at the moment. So we need to have a think about how we're going to populate this level. Well, first things first, let's go to our content drawer, and I want to open up the medieval dungeon demonstration level, because we're going to pick this apart and try and figure out how the modular system of assets works. So the first thing to note is that it's quite hard to understand what's going on with all this moody lighting going on. So there's a button in the top left of the viewport that says lit, and this is the default mode that we're in. But you can actually view the scene in an unlit mode or a wireframe or lots of other options here. So if we click on unlit, you can see that this just shows us the textured surfaces of our meshes without actually giving us any of the lighting to confuse things. You could also have chosen wireframe, and that doesn't even texture the surfaces, but it can be really hard to figure out what's going on in this view. So we're going to switch back to the unlit view instead. And then the way I like to take apart these levels is to literally take them apart. So I go, okay, well this floor looks interesting, let's click on it and go, oh, okay, there's the outlines of a chunk of floor. This is what it means by being modular, is that the floor is made up of loads of tiles that are all the same size. And if I wanted to check that out and see what size this is, then just move the tile and you're going to see, okay, that's what the tile looks like. Cool. Okay, what else do we have? What about this wall? Is this something interesting? Yeah, okay, so it's created another tile here that acts as the wall, and you can see that actually the plank of wood and the chains are all separate actors here entirely. So you've got this wall, and it looks like the wall is the same size. look at the arch panel, you can see there's a couple of different building blocks. It's very much like Lego. If you've ever played with Lego, you've got a single piece, you've got a double piece, you've got this triple piece here as well, then you've got the central block. And what about these pillars? So look at the pillar. Yep, that's just its separate thing, and we've got the arches are separate as well. Now, you might want to be making a note of the name of these meshes so we can bring them in to our own scene later. So if I click on the floor, you can see that the floor mesh, I click on General and scroll down to the static mesh selected and hover over it, you can see it's under the dungeon folder and it's called SM Floor. Now, I did mention that the crypt is slightly different down below. So down below, we've got a slightly different looking floor. And if I hover over the mesh there, it's called crypt floor. It's actually slightly smaller, I think. But we can easily check this out by going to a little 4-pane view that we can get to in our viewport. The top right, there's a little 4-pane icon. Click on that. Then that splits out our viewport into the 3D view that we're used to, but also a top-down, a right side, and a back side view of our level. And we can move around this to see what the different sizes of things are. In fact, if you were to middle click in this view, you can see it actually starts counting in Unreal units. So I can try and select from the top to the bottom and see that the floor is 500 units or 5 meters, and I could go and have a look, and it seems like the floor is the same in the upper levels. So if I select a floor that is just a straightforward SM floor and then middle click and drag to the bottom, you can see, aha, no it's not. It looks like it is, but it's actually 600, so it's 6 meters. So the upstairs works on a different scale to the downstairs, and we'll have to just bear that in mind, that these are actually slightly different scales, and we may want to choose to use just one of them or multiple. We can see that we've got stairs as a component that we can use. They're modular as well, so you can make the staircase as long as you like so. And we can have a look at the ceiling height as well. So if I take the back view and I have a look at one of the crypt walls, so if I look down in the crypt and select one of these walls like that, and you can see the mesh is called crypt wall. And if I go and find that highlighted wall in one of my side views, then we can check out how tall a wall is in the crypt. Looks like it's 450 units versus perhaps a wall that's asset pack build out. And then we've got assets, we've got 600 wide elements. We're going to be doing basically a floor by some sort of obstacle, doors or secret walls, secret passages, a trapdoor, that sort of thing, which we can later add a moving component to so that we can open it up and the player can explore the level more fully. And ask yourself, what is the puzzle going to be? What's going to make it challenging for the player to find the way through your level and explore your design? So pause the video, have a go, be creative and be inspired by other students' work. So once you've made a design, doesn't matter if you don't think it's particularly good, go and share it in the discussions for this lecture. Pause the video and have a go. Hello and welcome back. So I think it's quite instructive for us to take a look at literally the first drawing I drew of the level that we're going to be building, and it's pretty rough, so I just warn you, it needs some talking over. Basically, this is as rough as it gets for a level design sketch, right? So we've got over here the entrance doors, and I just kind of drew a pair of doors. My drawing's not particularly good here, as you can see. I had a table and chair just like they had in the demo level, and then I've got 4 cells here, and we know that we've got this kind of blocky level design. So we've got 1 square here, then an empty square, then a square here, 2 empty squares in the middle, and then an empty square here, empty square, square, etc. Then I've got a staircase that leads down to the next level, and we've got a slightly smaller set of things down here in the crypt. What I had originally considered, and I don't think I'm going to do this actually in my final design, but I'd considered we have a corridor that goes both ways, and it initially looks like, where do you go? and there's this actual secret pit here that drops you through, and then you've got the challenge of trying to find your way out in this under corridor here. And in the under corridor you have to go and steal something. It gets blocked off by some rail over here, and so you need to put a vase in its place. But then you've also got to push a coffin from, or pull this table over here so that you can step up out of the secret pit again. So I had a few ideas of the different kind of puzzles that we were going to do, but I've decided to simplify this down to just the corridor that leads to this little section with a rail that blocks it off. Anyway, that's my very basic sketch. Obviously you can spend more time on this, but it's just to get an idea, and once we get in and building our level, you may find that your ideas change. So I'll see you in the next video. Hello and welcome. In this lecture we're going to be making this level from scratch using the assets in the asset pack and modularly laying out every single one of these 260 almost actors and making a level that looks something like this. And we're going to keep our outliner nice and organized at the same time by using folders. Let's dive in and see how this is done. So let's start. By opening up our new level, which is the dungeon level. It's the root of content for me, and I'm going to go ahead and open it. It's completely blank, and we want to be in our 4-pane view here in order to be able to place things down nice and easily. So what we're going to do, well, I felt bad for leaving you with this scrappy design in the last lecture, so I'm just going to show you how I then refined that just now to basically give you a better idea of what I'm trying to build. So here is the 2 levels separated out. This is the top level here on the right. You can see there's a courtyard section with some doors. We've got the 4 cells here with pillars, table and chair, this time labelled. We've got the statuette hidden inside this open cell, and the secret door here that the statuette opens, and then stairs going down to the lower crypt level. Here in the lower crypt, we've now got a dead end over here, some door, but it's closed, we can't get in. We've got the vase, which we're going to need later to open up our closing rails. It's hidden over here. And then, if you go around the corner in this crypt, you're going to find the open doors to the mausoleum, where there is the statue that we want to steal. We take that statue, the rails close, so we need to put the statue back. We need to then go find some substitute for the statue, this vase over here near the dead end, and then we can escape with our statue. So that's going to be the little puzzle. We're going to have to, first of all, find that we need to open the secret door. Then we're going to need to find the vase to open the statue. Well, how do we go about creating this with the components we've got? Well, control space to open up our content drawer, and then we can search for floor. So if I search for floor, you can see it's coming up with a bunch of different stuff, but what we're looking for is the SM floor. So maybe we can start with SM floor, and you can see it's going to come up with a few options. We've got the crypt floor, but we've also got our standard floor as well. So we need to decide where we want to start with our design. In my case, I think I'm going to start with the upper section and the courtyard, etc. So let's go ahead and start creating the courtyard. As you can see from my design, this looks like it needs to be 3 units by 3 units for this main inner section, and the outer section may as well be 3 by 2. So let's go in and create that. We're going to take a floor mesh and we're going to drag it into our top-down scene like so, and you can see that it's added it in here. So we can then, you can see you can drag it around pretty freely, but I actually don't want to drag it around so freely. We can restrict how we're dragging it by clicking on this plus icon here, or if you've got a bigger screen, it's actually going to be visible to you. And we're going to look at the grid snap settings. Now here we get to choose the increments with which this is going to snap. And in this case, I actually want to snap with fairly large increments of 1 meter, which will allow me to place things aligned on this grid that we are seeing. Now I'm just going to reset the transform so that this floor starts at the 0, 0 point, and we can start building out the floor for our courtyard. So we can alt-click and drag in the top-down view to start creating the courtyard. Now I want my X to be the forward direction, and in the X direction is where we're going to head to get to our goals. So I'm going to build out the courtyard around that. We're just going to drag these floor tiles a bit, and that should create us the courtyard. Now remember, we're doing this in the unlit mode because we have no lighting at the moment. Now just at the moment, just be following along, and in a second I'm going to challenge you to build out your own level. So just watch, see how I build with the level, and then we'll come back and do some more level building after that. Now I just want to take a second